Hi again. You should recognize that formula as the sum of the first n terms of an arithmetic series. Let's just check what those letters mean. A is the first term of the sequence. D is the common difference between the terms of the sequence. The nth term, therefore, is A with n minus 1 d's added onto it, and Sn just represents the sum of the first n terms. So that's the formula for the sum of the first n terms. But where does it come from? Well, let's look at what that Sn actually is. It's the first term plus the second plus the third, etc., etc., plus the second to last plus the last. So there's the first three and the last two in the sequence, and that's what it looks like. Now let's go vertical with that sequence. Let's write down the first three and the last three of that sequence, reading downwards. Now here's the trick. Let's do the same thing again, but reverse the order of them. There's the last, second to last, etc. And there's the third, there's the second, and there's the first. And now we're going to add them across, add them horizontally together, and see what we get. Well, the first pair adds up to 2a plus n minus 1 d's. So does the second, if you look at it carefully, and the third, etc., etc. And the last three do the same thing. So when you add the two sequences sort of in reverse order across, you get the same answer each time. Let's add those up. Well, there are n terms in the sequence, and so there's n of those 2a plus n minus 1 d's. So let's just summarize that. Twice the sum of the first n terms is that. So if we just halve both sides of that equation, we get the familiar formula, the familiar equation for the sum of the first n terms. Now that's the reason why it works. It's an informal proof of it, and that's it. That's all there is to it.